As this is the last module of this topic, rehabilitation of contaminated sites. So as an intro, in the 19th and early 20th centuries, mines weren't regulated and there were abandoned mines that were not able to be rehabilitated and were hazardous. Today, the government keeps a bond so that if a mining company does not comply with the rehab regulations, the bond money can be used. Most companies today want to protect their reputation, and some companies do even more than is required by law. However, there is a backlog of old mines that have to be rehabilitated, and the companies often no longer exist. So the government has to rehabilitate the mines at public expense. Also, we have to think about the rubbish, the waste that we produce, the environmental waste, the industrial waste, the commercial waste, and the domestic waste that we produce. Where does it go, and how do we minimize the impact to be more sustainable? The millions of tons of waste our society creates each year has to go somewhere. Some can be recycled, but what about the rest? In most cases, it goes to a dump. And as you know, we want it to be the last possible, that it should be like the last thing on the hierarchy of waste. We should dump it last. Waste dumps or landfills can either be a depression carefully designed and built, or an old mine site with the appropriate geology. Some methods that are currently applied to solid wastes include landfill. So 97% of all solid industrial, commercial and domestic waste is disposed as landfill. So when thinking about disposing in landfill, selecting a dumping ground for that landfill, we have to think about the geology that lies beneath the surface. The landfill must be sealed in such a way that any materials it contains cannot leak into the subsurface water system or surrounding rocks and soils. Faulting and fracturing destabilize the rock and make groundwater movements unpredictable. Fractures allow spaces for water to travel, which could carry waste into groundwater. Where do we put our wastes? Porosity and permeability of the rock also need to be evaluated for where we put the waste. Different rocks have different crystal structures, which can lead to differences in the amount of water that can pass through them. What kind of bedrock would create a good waste dump site? And of course, we have to look at the landform of the surface geomorphology, which is another important factor when considering the location of a waste dump. And we've talked about this in class already, why hilly sites should be avoided. Old mine sites are now being assessed for waste sites. If you think about it, an open-cut mine would be an ideal place to dump wastes. However, we must consider the geology before we consider it as an appropriate site. So for example, the Woodlawn mine in Goulburn, New South Wales, which is now no longer operational, is being considered. As a result of years of open pit mining operations, a huge hole has been left in the ground. The mine is located in an environmentally sensitive area. What does this mean? Well, it's near an elevated ridge that provides a watershed, like a drainage system, for Canberra's water on one side and Sydney's water on the other. When the mine was operational, special measures had to be done to ensure that waste from the mine site was not leaching hazardous material from the groundwater supply. Today, the Sydney Catchment Authority has advised that the site is suitable and watertight. What do you think some of the effects would be if we began dumping waste in this area and 10 years down the track discovered that hazardous materials were leaching into the groundwater? Landfills have some method in place to collect the water that has filtered through the wastes. Otherwise, the depression itself would fill up with water. Just look at the picture. That liquid, as we've looked at, is called a leachate, and it's usually contaminated. Most landfills are designed to have a sloped base with the collection pipes attached to the lower end to collect the leachate, which can then be treated and disposed of appropriately. It's very important, as we said, that it doesn't reach the water table, because this could have a huge implication on water supplies. When the landfill is full, it is then covered up to prevent water from getting in and creating even more leachate. This cover is usually several layers of plastic and clays to prevent water getting in, and also overlain with sandy soil to allow the water to run off the top so that it doesn't hang around here forever. A layer of topsoil and vegetation is then placed on top of the area and can be used for normal activities. Can you think of any problems with this system? A major concern is that the landfill fails to seal. Plastic liners and clay liners do not always provide a perfect seal and can allow water to pass through them. Landfill covers can also be breached, allowing water to infiltrate the waste. Another common problem is subsidence. When the contents of the landfill decay and break down, they settle and compact further. This can affect the cover and structures built on top of the sites. For these reasons, landfill sites are monitored very carefully, both while they are being filled and well after they have been covered.